Hey guys, I'm Timmy. Today we're going to look at a General Electric Model 601 radio from about 1950. It's an interesting radio that's both battery powered and AC capable, so it's got some interesting things about it that are a little different than the radios we've done so far on the channel that were All-American 5s. This is not an All-American 5, which I'm glad to say is a little different, so we'll jump right into it and let you guys have a first look. This will be a multi-part video series, and this one we managed to get some life out of the thing, but I've decided I'm going to do some more work on it down the road here, but more on that later. This is 3 Old Tech Tunes.
Alright, the first project on my new workbench in my new office. Just got a new office building kind of sorted right beside my house here, connected to it. It's allowed me a new work from home space as well as an official workbench, something I've not had. My home's fairly small, got lots of kids, so they let them have most of the space, but now I've got my own area, so let's tackle a radio. Now this is a radio I've had for 3 or 4 years. Got it from Nathan. He found it in his uncle's barn that they were cleaning out at one point. It's a General Electric Model 601 from 1949 or 50, around in there. It's got kind of a cool, I believe it's plastic, I don't believe it's Bakelite. Not for sure on how to tell. It's got a full cover that was originally hinged. You can see there were hinges down low here. There, but it's damaged, unfortunately, is due to time. See a few issues here. We've got a 4-tube radio. One thing I've already figured out is interesting. This was an AC or DC radio, but it's not necessarily an All-American 5. This is a battery plug for I assume a battery pack you could get for it. It may have had a battery holder of some sort for A and B voltages. But it also does have an AC power cord that's got one of these spectacular 1950s or 60s replacement plugs on it. Goodness. That'll have to go. Noticed one thing. We have 1 and 3 volt tube filaments here. So really curious what we're going to get into when we get in here. So there's what looks like an AC plug port right there. Don't know much about that. So this is this one's a little rough. See, we got a flying speaker wire here that's not connected anymore. But the tuner is still strung. Let's go have a look at the front real quick. So it's a handsome maroon radio. Noticed kind of an interesting effect when I turn the tuner, it tends to rotate the knob, so the tuning dial or pulleys must also go around the volume and power control. But it is technically functioning there in that regard, so we'll try to preserve that, keep it in good shape. And of course, we'll do our best to clean up the case if we can get the chassis to function. Looks like to get this out of the chassis, remove that. And that one, looks like it's connected. Looks like these are not. Looks like I just need a flathead screwdriver. The speaker, is it an attached part? That's what I'm trying to figure out now. Cannot tell. It's obviously clipped at the top. It's a pretty fragile case. I don't want to damage it. However, the handle with its springs are intact. That's kind of cool. So I'm going to go ahead and take these screws out off camera and see where we get after that. Always remove those screws, so let's see what we get here. Oh boy, so the speaker does not come with. We're just going to tip this up since that lead's there. I may just cut the lead. So it detaches. Those almost look like they hook directly to, oh, that filter cap's rough. But those just connect directly to the transformer, audio transformer. Tell you what, let's just desolder that. Oh, well, that works. Just kind of twinked off there when I put the desoldering iron on it. So you may be wondering why I had not powered this up on video. At one point I did bring this up on the Variac, but I did not shoot video clips of it and did not get tube filaments. So, but I didn't check it any further. I opted to wait until I could be on video with you guys. Let's get this moved out of the way. So, got our antenna connectors, got a coil loop antenna here. A lot of things are melted into the plastic. Is this plastic? It's so, this could be bakelite. I can't tell, it's kind of brittle. I'm gonna say it's plastic. I was gonna say it's been disassembled before. Judging on how this hole looks for the lower screw, see how that's been sheared off? I knew there was a tape mark right here, like it had been taped down before, so this thing's pretty rough. This one's okay. They both threaded okay, the screws. I didn't have any trouble with threading the little screws that hold the chassis in. So get those put in a drawer here where we don't lose them. So we have a sealed chassis. Has it been painted on? What is going on here? I don't think I'm the first person in this rig. And we've removed that one bolt and the bottom is coming loose here. Don't understand the black paint. How odd. Ooh, goodness. Well, this is going to end up becoming our first free-flying capacitor and component radio on the channel. Got some replaceables here. Oh, it's so brittle. So what we're gonna do, oh man, this one's gonna be more challenging than the simple circuit boards we've done. And I've wanted to do a radio with a chassis like this, just a free, no board in it kind of deal. So the case on this radio is so rough that, you know, I don't know how worthwhile it is. We can get the chassis in working order, but we've got the broken hinges on the back, and we've got the speaker doesn't have all its clips. See where the bottom clips are missing, which guarantees this guy will be a rattler. Those may actually just be broken off, I don't know, but it's going to rattle, rattle, rattle. And that's granted that trusting that the speaker's okay. So we didn't look at this yet. That's always fun. The tag. So a lot of radios this is missing. This one is still here because it's on the inside. So A battery supply 7.5 volts. B battery supply 90 volts. If we do get this working, it might be cool to try to build some battery packs to get this guy going. That'd be fun. Come up with some batteries that we can, maybe get some old 45 volt batteries or something, or 24 volt batteries, and put them in series and get the voltage we need. Okay, well, tell you what we're going to do now. We've had a look, we see what's in here. We've got wax paper caps here, here and here. That might be what this is. This is before they started implementing some of the later safety features you'd see. And sure enough, you remember I said the knob tended to move when you turn the tuner. Sure enough, it's using that as a mount point for the dial string on the tuner. So let's see, we're turning our variable capacitor gang there. What are you? I bet this is one of those big resistors. Remember I said there was a big high value resistor in series in the power input there. That's probably what that is. Because that's going to get pretty warm when it's on AC power anyway. So, all right, well, let's start testing tubes. Okay, we're going to go through each tube. Start with the 1R5 converter. I'm not going to go through the setup of the tube tester. If you want to see that, go check out the white Philco video. I'll put it in the links below in the description, and it's up in the corner here if you've got cards on screen. And we're just going to go through each of these and check their emission and grid leakage. So starting with the 1R5. 1R5, let's look at emission. Showing about a little over 90, so that should be fine. Grid leakage, quite good. Go to short test. Rotate switch D through all positions. We will get a short indicator if there are any shorts, but I doubt we'll get any. Okay. 1R5 converter tube is good. For the 1T4, the IF amp. You know, I tested this some time ago and the radio didn't do anything, but I thought the tube filaments weren't lighting. But I wasn't thinking, these are 1-volt tubes. They don't even get hot. You can't see the filament, at least not in broad daylight. At least it didn't seem like, but the calibration comes right up on them, so. That one's showing just over 80, well enough into good on emission. Grid leakage, almost none, that's great. On the lower score there. Run the short test. We're good. So, yeah, I mean, this doesn't even get warm. I mean, most tubes you can't even touch after a moment. So the IF amp tube 1T4 is good. Now the 3V4 tube, which in this radio is used for power output, or you could say amplification for the audio. So check our emissions, right under 100, plenty enough. Grid leakage, pretty much none of that. Short test. Not showing any. Great. Okay, 1S5 for the detector and auto volume controller AVC and the AF. Get that calibrated up here. And it came right where it needs to be. We'll call that warm enough. Emission's good. Well over 100. Grid leakage. None of that either. These are a good set of tubes. These are superior to the ones in that old Philco, and it's a pretty solid receiver, so. Short test. Looking good, looking good. All right. Well, we'll put these back in the radio because there's nothing wrong with these tubes. Okay, guys, we got the tubes back in here. Our next mystery to solve before we do much else, we need to figure out if the speaker works. And we need to know all about this, so we're going to go back and look at the schematic and study on this a little longer. See if there's a missing insert for that in order to use AC versus the battery or what.
Okay, we need to understand what we've got going on here with our power supply circuits for this radio. AC resistor, there's a diode here. This is a photofact, sure looks like. It's got photofact notation, I think. Yeah, it is, okay. We don't have the whole photofact, so we don't know what this is. We may have to get that. It would make my life easier. Anyway, I digress. So M3 is probably that little rig. You have A minus and B minus on the pins without the guide pin. A plus and B plus up here. So if this switch is in the position that's on the schematic, if we hook a multimeter to either of these pins, and turn the volume control, the switch on the radio, with the other end hooked to this side of the plug if we can determine it. It shouldn't be too hard actually. We can tell what position these are in without anything in that port to open those connections. So it has two, it's got one that swings between these two here. That makes sense because that cuts off the B plus feed when it's in AC power mode. That's connected here, right? Because that's B plus, right? And B voltage, yeah. There's a switch here on the volume control too. Okay. Yeah, you got A plus here, normally disconnected, or can be disconnected. A plus, B plus. Yeah, because if you're on AC, it's running through those resistors and then starts hitting tube filaments. Because you got pin 7, pin 1. That's what you connect in line to get the filaments lit. Then it goes to ground. Okay, perfect. All right, let's get the meter out and do some more tests.
Okay, we're going to test that theory here. So this plug, as you've seen on the schematic, is that's just a guide plug. It's not a wire or anything. It's just got a thing to pull on. That's creative. So I got that solder on there to pull, which means based on their schematic drawing, which we'll put on screen here on the left, you've got A plus, B plus pins, and you have, these are common to negative or the neutral side of the AC line. So, and indeed they are connected together. So being as these radios, almost all these transformerless creatures are connected on the neutral side with the switch, which is just how it is. We can alligator clip connections here, and we should be able pretty quickly. We'll set our multimeter to diode check. So the nice part of that is when we hook the connectors together, we get a tone. Yay, and then go all zeros on display. So get you guys in there real good and tight here on our power, can't really talk, connections here. We have this leg of the power switch clearly connected to the same part, a part of the AC line. I am curious what side is switched, so let me get another alligator clip to put on here like that. Okay, so that makes sense, because that's switched on the negative, remember? Not the negative, the neutral. I am always doing that in these 3OTD videos. Neutral and negative sound the same to me because it's technically like a false ground, you could say. So there. So no matter what position we're in, we're probably, yeah, hot to the chassis. But when we throw the switch in, this probably becomes hot. Yep. So it's switched. So let's test our theory on our plug here. Get your zoom back out. So let's connect to that, what we know to be one of those pins on the negative half of things. Let's throw the power switch. So that means that that switch is open in that manner. How happens if I open it by hand? Let's see if I can do that. So I believe that means with nothing in that slot, we should be using AC power, right? Yes, based on that second switch in that schematic. That's interesting, okay. You know, I think I want to hook this speaker up, even though I don't have my tone generator with me today. I've left it somewhere else. And we'll see. There's a couple ways we could test that. We'll just assume it works. Well, you know what? Let's test the resistance on the speaker. Okay, let's test this speaker out. It's probably a 4 or 8 ohm speaker. We'll be able to test it with the tone generator later, but we may be able to test it with the radio chassis here in a minute. So, I've got these connected up. Let's go to what are we showing there? 0.1. See if we trust that. Let's use the probe directly. 1.2. Need to get me some probes for this that hook in. I think I'd have all that I do for the oscilloscopes. That resistance is not enough, but it's not infinite, so I think that speaker probably works. Okay, for our power up test, I don't currently have a dim bulb tester, which would be better. We're going to get one of those going, so don't worry, old radio fellas. But we do have an RCA isotap, an old TV isotap that I bought off of eBay sometime a couple years ago, and we've used it in a few videos now. We've got the ugly Variac from the N9CMM collection. Check out a video about that item up in the corner right now or in the description below. So to set this guy up, you want to set this to your line voltage or as close to it as you can. We're going to plug into this power strip and we're running 118.4 to 118.6 steady. So that's what our current line voltage is. So we're going to use 120 in that case. I'm going to round up. So we'll get that plugged in. I want to use this, since it's a kilowatt, see how many watts this radio pulls. It's rated on its label for 15 watts. So we don't want to rig this guy up, and we'll probably put it in the Variac first for a while and just bake it for a while. Alright, I came up with something. I don't know what I was thinking. So we've got this set up and powered up. You can see we're showing on the medium tap 121 volts out of the ISO tap, 121.7. And I decided we should be able to plug the Variac into this. And I don't know how much it will draw on its own, if any. One-handed tricks. We're going to go ahead and flip it on. We'll just leave it all the way down. Check if it's working anyway. Yep. What does it draw? Put it up on 120 as well to test this. So the Variac draws 6.4 all by its lonesome. So it's got some loss in the variable transformer. Guess that's expected. So, or usage. Drops our voltage a little bit too. So we can trust it's 6.2 to 4-ish. Probably more the more we tell it to draw. Yep. So that's all the way up. Way more than we'd ever use. If we cut the power, what are we at? 40-ish volts? Yeah. We draw 5.5. So we can say we know the radios. If this shows 30 watts or something, we know we're in trouble. It could show 20 to 20-ish if it's behaving right. 20 to 21. And this is 15 watts, and we don't want to go, crazy. So, all right, let's get this rigged up. Okay, at this point, I went through the whole rigmarole of testing, power up of the radio. This Variac that I have, this got me in the video with the General Electric radio, the maroon one we did a few months ago, which you can see that up in the corner here if you'd like, where I went through the whole thing trying to power it up and couldn't quite figure out why it was completely dead. Well, this Variac, the guy that designed it, he put a breaker in line on the back of it between the plug on the front and the variable transformer. And so you get a situation where the volts come up on the meter on the front, but it still has no power at the port. So somehow that got flipped again when I had it on the shelf or something, and I wasted like an hour trying to figure out why this radio didn't work. and could not determine it. So we're going to jump over that, which you see flying by in the background here, and get to the part where I actually figured out the Variac was my culprit. So you can bet in any video going forward, you're going to see me testing that plug before we do anything else. Okay, let's try this experiment again. Still at 5 watts there. Variac is on, but no volts. Let's go ahead and give this a little bit of juice. Give about 40 volts. 5, 4. This thing only draws 15 watts. That's a lot lower than an AA5, which is usually 40 to 60. We're not powered on. That would matter, wouldn't it? Lots of volume. It's interesting, we didn't have voltage earlier to set off the AC. We're drawing 6.6. That's good. I think it may actually be live. Nothing smoking, that's good, right? We're only at 40 volts. Come on, baby. Put it up at 70. Oh, this is good. This is good. We're drawing 8 watts now. We know it's about 6.4 with no load. That's good. I think the circuits are living, guys. I gotta deal with that breaker. That's the second video I've made for 3OTD where it's bit me. Start checking voltage on it every time I use it now. Such a tricky radio because you can't see the filaments. They're just not bright enough. Due to those low voltage tubes. Okay. Come on, we still could have a dead speaker. Getting here real close to it. Yeah, I'm not getting anything there. Well, let's brave it. What do you think? 90. 10 watts. These circuits are working. They wouldn't draw this much otherwise. Hear that? Something's happening here. At least got audio circuits running. Come on. It's such a train wreck. I'm gonna go ahead and give it the full deal. We start getting it at 100 volts. I wonder if that's because the tubes are so low voltage that you don't get much activity out of this radio until you have full power. Yeah. So I got these LED lights in here that are a problem. Let me fix that. Alexa, turn off the office lights.
Okay.
Bingo. I guess radio's just fine.
Twice, and then Fallen and Yukon coming in as arguably the best team in the NCAA tournament, just manhandling opponents right now, winning by a total of 62 points their first games as far as the scoring differential in all three of them combined. We do have one NBA game happening, and that seemingly is under, not so much the spotlight, I should say, because of college basketball, but Andrew Nembhard, who spent time with Gonzaga, is playing for the Pacers, and he's got 10 points, so the Pacers through one quarter are trailing the Hawks 39-35. Women's college basketball Sweet 16 action. I will leave you with this, guys. We did see 4-seeded UCLA fall on the road in South Carolina against the 1-seed South Carolina, 59-43. So the Gamecocks led by
You legitimately cannot see the tube filaments in this.
3-5-0 on the season as they get to the Elite Eight.
So low voltage.
And lastly, third-seeded Notre Dame loses to 2-seeded Maryland, 76-59. And guys, relatively speaking, because we don't have a whole lot of NBA championship, and I'll tell you what.
Alright, so this thing works pretty well on a further out station as well. Especially if you touch the antenna loop, they get a little more receptive.
Gonzaga's all-time leading scorer. We asked him about this journey that he's been on the last 4 years. It's been crazy. I mean, coming in as a freshman, I never thought I'd have all these accolades.
This thing's a pretty solid performer with all its original capacitors.
So that brings us to now. As you can see, I didn't leave it alone. I've decided that I'm going to refurb this. We're going to replace all the capacitors, even though it's in working order, for safety, and honestly because I need some experience with a non-printed circuit board antique radio, and this one's pretty rough, you know, as we've seen the case and such. So we're going to make it the guinea pig. I'm already quite a ways in. Won't go into much what we got going on here, but some of you experienced radio guys may recognize a few things. So this will be in part 2 and probably a part 3. So, because I have enough content at this point even for part 2. So that episode will be coming around the corner. I don't know if it'll be the next one, but it will be soon. And when it is created, if you're seeing this before it's ready, it will be linked in the description below and in a playlist here on 3 Old Tech Dudes. Till next time, for Justin and Nathan, I am Timmy, and this is 3 Old Tech Dudes. Thanks for hanging out with us here on 3 Old Tech Dudes. Please subscribe to us here on YouTube for more tech old and new, tinkering at the workbench, repairs, ham radio, electronics, computers, and more. Please like this video and share 3OTD with your friends to help us grow the channel. We tweet at 3 Old Tech Dudes 1 on Twitter, and you can keep up with us on Facebook. Just search for 3OTD and look for our logo. Thanks so much for watching.